Among my many goals for you in this course, I hope that you will become a more confident problem solver, and in particular, problems like number 32, where you're having to apply a lot of different background information that you know, or in different types of math that you've worked with. And in number 32, this is kind of a classic case because there's some geometry involved, um, and some little upper level thinking with some algebra in it. So that's why I selected this problem, and it's the only one in this video so that you can focus just on this one example. Pay attention to the strategy, how I read the problem, what I write down, when I write it down, and try to adapt your approach to sort of use mine as a model. Okay, let's start the problem. My first suggestion is, as you read, stop and record any information that the problem gives you as you come to it. So the first thing we read is that Jake stores a small cache of 4-inch diameter snowballs. Okay, well, if you've just read 4-inch diameter snowballs, then you already know that we're going to be talking about a sphere. Now, we won't write anything down about that, but that's just kind of even what goes through your head should be affected by each phrase you read. So we have 4-inch diameter snowballs in the basement freezer, and he's unaware that the freezer's self-defrosting feature will cause each snowball to lose about 1 cubic inch of volume every 40 days. So let's write that down. 1 cubic inch every 40 days. And we're going to make this negative because it's losing that amount. And that is a rate. Anytime you have a quantity in one unit, in or for or every, or however they phrase it, with another unit of measure, that's a rate that we're talking about. Okay? And since this is the same amount over a certain time interval, then what that tells you is that this is kind of your rise over run. So now we'll keep reading. He remembers them a year later, and we're going to approximate 1 year to 360 days. Now that's in the problem just to make the problem easier for you, but that's how we're going to start. And then goes to retrieve them. What is the diameter then? So what we are charged to find here is the diameter after 360 days. Okay? Well, let's get started on some computations. Well, the first thing we have to do is to find some way to relate the diameter at the beginning of the problem to the diameter 360 days later. So the only thing we have that we can do that with is the fact that this is a sphere we're talking about, so we have to work with the volume of a sphere, which most students don't remember until they see it, and then they remember seeing it somewhere, which is generally written as 4/3 pi r cubed, but you can also write it 4 pi r cubed over 3. And for our purposes, that's what we're going to do. Alright, it just makes the algebra easier. So the first order of business is to figure out what the initial volume was of one snowball. And we're going to do that by substituting what we know into the formula, and we were given the diameter as 4, so we're going to plug in 2 as our radius. So we're going to have 4 pi times 2 cubed over 3. And then and let's go back and put a little 0 subscript on our volume, just to remind ourselves when we look back at this that this was the volume at the beginning of the problem, or the initial volume. And so then 2 cubed is 8 times 4 is 32, so that gives us 32 pi thirds cubic inches, and the approximate value of this is 33.5 cubic inches. Well, then we want to use what we've just found and combine that with the fact that we know that over time these snowballs are losing their mass or volume. So we're going to put the volume in the subscript 360, means after 360 days in this problem. So it starts at 33.5 approximately. Now I don't want you to round values that you're using in the middle of your problem, but if you use your calculator, you can save the exact value and use more decimal places so that it doesn't hurt to use the decimal version of this number. So we're going to start at 33.5, but we're going to lose 1 cubic inch for every 40 days 360 times, because each one of those days we're going to lose 1/40th of a cubic inch. So that's the equivalent to 33.5 minus, and let me show you the arithmetic here to, again, my never-ending quest to help you get more comfortable with these things. The zeros would cancel off, and then if you've got the 36 and the 4, I can reduce by a factor of 4 to make that 9. So this is 33.5 minus 9, which gives me approximately 24.5 cubic inches. So now I know the volume after 360 days, but what I was asked to find was the diameter. So I'm going to work backwards with the 24.5. In fact, I'm going to move on to another screen so I have a little more room to play. But I'm going to use the fact that the volume after 360 days is 24.5 and set that equal to the volume formula, 4 pi r cubed over 3. And then if you multiply both sides by the reciprocal, and again, trying to help you be a better math student in terms of showing your work and finding your answer. And you don't need to pick your calculator up after every step. That's another thing I want to show you here. I'm going to multiply both sides by 3 over 4 pi. So 3 over 4 pi times both sides. Well, when I do that, I have r cubed isolated. So now I know that r cubed is equal to 3 over 4 pi times 24.5. That decimal looks messy. Let me fix that. There you go. Alright, and then I only need one more step to get r isolated. And I do that by taking the cube root of both sides. And then I type that in my calculator. Now if you have an Inspire, there's actually a template for that, and there is a way to do it on the 83 or 84, but I can't call it off the top of my head. So a way around that, and that's why I don't remember it, because I've found workarounds. But another way to put this in your calculator is by typing everything in just as you see here, making sure to put parentheses around that fraction if you don't have a fraction button that you're working with, and make your exponent 1/3. An exponent of 1/3 is the same thing as a cube root. But however you get that in your calculator, you're going to end up with r is actually approximately, let's make those approximate signs there, 1.8 inches. But we weren't told to find r, we were told to find the diameter. So we're going to double that to get our diameter, and clearly if I double 1.8, I get 3.6 inches. And that's number 32. And your last video for 1-4.